Hello everybody, how are you all doing? Well, in today's video, let's discuss an advanced level of functions. Till now, the previous videos were all about basics, which we have already learned in SSC class 9, etc. But this video is gonna be exclusively for intermediate first year, and here the topics we're gonna cover are ordered pairs, Cartesian product, properties of Cartesian product, and lastly we'll talk about relations. What are these ordered pairs? Now this hefty definition can definitely be confusing. Let me tell you what they are. Now if I have A comma B, let me take A comma B as one pair and the other one B comma A. Alright. Now these two are definitely the pairs. Now, an ordered pair is such a pair which consists of two numbers that are written in a fixed order. Now, if I'm talking about an ordered pair, it means it has something to do with the order of the numbers. Alright. Now, ordered pairs over here means that this A comma B and B comma A are not same. Alright. That means if I say 2 comma 1 is one pair and on the other hand I have 1 comma 2, are they same? No, they are not same, and that is what ordered pair actually tells us. Ki A comma B and B comma A are not same. But in the previous video we have discussed about sets, isn't it? Here the exception case is for a set. Now in sets, the order does not really matter. Now if I say A equals to 0, 1, 2 and B equals to 2, 1, 0, still they are equal. They are known as equal sets. Why? Because every element is present. That is what it matters. The order of the elements does not really matter. Okay? But whereas when I talk about these pairs, they are completely ordered. That means they are written in a fixed order, and if their order is changed, then they would not be same. Now you might ask me, why did we start with this ordered pairs? In order to understand Cartesian product, it's important to understand the basic concept that is ordered pairs. Alright? Well, this hefty thing's on the screen. Haha. Let me tell you what a Cartesian product is. Now here I'm taking two sets. A is equal to 1, 2, 3. And on the other hand, let me take B as x comma y. Now do not wonder any hefty stuff over here. Alright. Now I'm saying multiply A and B. I'm gonna take the product of A and B. Now how to do? How to find out the product? Well, that is what a Cartesian product tells us. You're going to take the first element of the pair from set A and second element from set B, or the second set, that is set B. Now what do I mean by this? This is my set A, this is my set B. I'll take first element from set A. That means I'll take 1. Any element that is there. Okay. It does not matter. Order really does not matter over here. Even if you take 3 first, it does not matter. Alright. Just take any one element from set A only. You'll take the first element from set A. Then you'll take the second element from set B. That is, let's suppose I'm taking X. So this is one pair. I'll tell you what the product is. Now again, take one element from set A and multiply with set B. Now, you're getting confused over here. If you take 2, then it would be quite dissatisfying for y over here. Y is not getting multiplied with 1. Why is that so? So let's write down 1 comma y. So take one element, multiply with 2 elements. That is what is the concept here. Alright. Then take one element from here. Multiply with 2 elements. What is that going to give me? 2 comma x, 2 comma y. Now, I'm going to take 3 over here. Multiply with xy. What is it going to be? 3 comma x, 3 comma y. But one thing that you're going to note here is that the elements from set A will definitely be at the first. You're not going to write y comma 3. Why are you not going to write y comma 3, everyone? Because multiplication is commutative. My friend says कि I'll write down y comma 3 instead of 3 comma y over here. Now I say to my friend that, my dear friend, that's not possible. Why? Just now we have discussed about ordered pairs, right? Which means that y comma 3 will not be equal to 3 comma y, and that is why here comes a twist in the Cartesian product. That is, a into b will not be equal to b into a. This is one property of Cartesian product. Let me show you how. Now this is a into b. Now in the same manner, if I need to find out b into a, I'll open the curly brackets right over here. Now if I need to find out b into a, I'll take one element, multiply with all the 3 elements. What is that going to give me? X comma 1, x comma 2, x comma 3. Then I'm going to take y with all the 3 elements. Y comma 1, y comma 2, y comma 3. Now certainly, if you look over here, any layman who does not listen to, who has skipped the part of the ordered pairs or has not learned the concept of ordered pairs would think that a into b is equal to b into a. Why? Because here we have 1 comma x, x comma 1. My friend says they are same. Ha, they are same. No, it is not like that. 1 comma x will not be equal to x comma 1. Okay. Now, my friend said that 3 into 2 was 6 and 2 into 3 was also 6. So 1 comma x will be equal to x comma 1. That is not correct. Here we are talking about Cartesian product where the ordered pairs come into picture. And over here, order matters. Here, let me write down this. Order matters. Alright, that means if you look over this, 1 comma x is not equal to x comma 1, 1 comma y is not equal to here y comma 1, and 2 comma x is not equal to x comma 2, 2 comma y is not equal to y comma 2, and 3 comma x is not equal to x comma 3, and 3 comma y is not equal to y comma 3. The order matters. That is why I have first discussed ordered pairs and then I'm coming to this hefty topic. Alright, this was about the Cartesian product. Now, have a look at a into b and b into a. They are certainly not gonna give you the same answer, isn't it? That means here do I arrive to the conclusion that, my dear friend, a into b is not equal to b into a with respect to Cartesian product. And that is what this hefty statement state. Here, for two non-empty sets, say A and B, the first element of the pair is from set A. The second element is taken from set B. That is what we have done. We have first taken it from set A and then we have multiplied with set B. Now on the other hand, in B into A, we have to take the element from set B first because B is written first. And then you need to multiply with each element of set A. Alright, now that is how we arrive to this conclusion. To tell this to our friend that A into B is not equal to B into A with respect to Cartesian product. Now here, the collection of all such pairs gives you the Cartesian product. That means here, whatever is written, it is known as the Cartesian product. The ones which I'm highlighting it in green, this is the Cartesian product. This is the Cartesian product. I hope it's clear. Let's together move on to discuss the properties of Cartesian product. First and foremost, already discussed that A into B will definitely not be equal to B into A. Here we have, if any one of A and B is an empty set, then A into B is also empty. Now let's say A is equal to 5. What do I mean by A equals to 5? Well, I mean that here it's an empty set. Alright. Now B is equal to, let's say, 1, 2, 3. Now this property says that A into B will be equal to 5. That means if you multiply A and B, it will be equal to an empty set only. Alright, if any one of A and B is an empty set, then A into B is also empty. Now what is this? Well, it seems to be like Latin for me. Let me tell you. If suppose, here let's forget all of this that is on the screen. Alright, now let me tell you, let's suppose say A equals 1, 2, 3 and B equals 4, 5. Alright, these are two sets that are there. Now how many elements are there in the set? 3 elements. Here we have 2 elements. Done? Now here, if I need to find out A into B, how do I find out? Tell me. 1, I'm taking first element, multiplying with these 2 elements that are there in set B. Then with 2, 4, 2, 5. Then 3, 3, 4, 3, 5. Now my friend says that I have a confusion in understanding how many elements here would be formed. See, 1, 4 itself is one element in the set. 1, 5 is another element in the set. 2, 4 is another element. So my friend asked, I have a huge confusion in the number of elements that are formed as A into B. Now it is going to be equal to 3 into 6, 3 into 2 over here. The number of elements in A into number of elements in B, that will be equal to the number of elements that are formed as A into B. Now that is what this property says. Let's first verify this. 1, 2, 3, 4, 5, 6. Now my friend is happy because I have told him that the number of elements in A, if it is multiplied with the number of elements in B, then you will get the number of elements that can be formed as A into B. Alright, that means in A into B, how many of the elements that are there, they can be calculated as 3 into 2, that is number of elements in A into number of elements in B. Now let me quickly rub this. Here you have this, that here n represents number of elements in A equals P, then number of elements in B equals P equals Q, then number of elements in A into B will be equal to P into Q. Here it is 3 into 2, that is 6. That is way too simpler. Now let's move on to the last topic for today, that is relations. Any subset from A into B is called relation from A to B. Hey, what is this? Let me tell you. Here, if I have A as 1, 2, 3, let's say. What happened? So yes, let's say this is 1, 2, 3. Then I say my B as alpha, beta. Alright. Now what is A into B? Come on, let's be quicker. A into B will be equal to 1 comma alpha, 1 comma beta, then 2 comma alpha, 2 comma beta, then 3 comma alpha, 3 comma beta. This is how we do it. Now this is A into B. Now my friend has made two things over here. Let's say f equals to 1 comma alpha, 1 comma beta. Now don't wonder what these are. Let me tell you. Alright, 2 comma alpha, 2 comma beta. Now I'll tell you what is happening over the screen here. Here, my friend has made two group of sets. Now here, he says, oh, where are curly brackets, my friend? Alright. Now, here he says that there is a relation from A to B. And guess what that relation is? Now, I said him that the relation between A and B would be, here, have a look at this now. Here, A into B that is there, keep these elements into consideration and the elements that are on the screen. Now, f is equal to 1 comma alpha. Is it present in A into B? It is there. 1 comma beta is also present. Fine, done. Then look at G and A into B, right? 2 comma alpha is there, all right. 2 comma beta is there, all right. Now that is the relation from A into B, from A to B. Now let's quickly forget everything and have a concentration of A into B. I'll tell you again. All these subsets of A into B are called the relations from A into B. A to B, sorry. That means 1 comma alpha over here is called the relation of A to B. Then 1 comma beta over here is called the relation from A to B. 2 comma alpha over here is called the relation from A to B. 2 comma beta, 3 comma alpha, 3 comma beta. All of these are relations which are carried forward from A to B. Alright. On the same manner, if I take B into A, I would get some data over here. I would get some set of elements that are there. Right. All of these elements that are there, let's say 1, 2, 3, 4, 5. All of these are the relations from A to B. These are known as relations. Now, if you're wondering how many number of relations could be there from A to B, then there are 2 to the power of PQ relations from A to B. Well, that dives us to the end of this video. Make sure you hit the like button, share and subscribe. Thank you.